Creating a staging site starts by clicking a clone button, but behind that click, you trigger a massive computational stress test on your server. Plugin-based staging tools like WP Staging or Duplicator Pro are highly effective, but they don't spin up a separate server instance. They execute entirely from inside your existing WordPress installation. This internal approach bypasses the need for expensive managed platforms. The trade-off is that the clone operation is forced to run on the exact same hardware, memory, and processing power that is actively trying to keep your live website online. A safe, reliable staging environment isn't determined by the plugin you install. It depends entirely on the specific resource limits of your hosting plan. This animated diagram shows exactly what happens under the hood. The moment the staging plugin activates, it launches two massive, simultaneous streams. First, it executes a complete, recursive read and copy of your entire file directory. At exactly the same time, it fires off a heavy database query to export every single row of your MySQL database into a brand new directory. Now add your live visitors to the equation. Every read, write, and export command is firing while your site is actively trying to serve incoming traffic. All three of these actions, the file copy, the database export, and your live visitor requests, are competing directly for the same limited pool of memory and processing power. Every single staging clone triggers an aggressive resource competition that tests the absolute limits of a shared server. To understand this competition, look at the schematic of an isolated hosting container. Those empty hexagonal slots are PHP entry processes, commonly known as PHP workers. They represent the strict number of concurrent requests your hosting account is allowed to process simultaneously. Standard, mid-tier shared hosting plans typically provide around 15 of these dedicated workers. A typical staging clone takes 3 to 6 minutes to complete. During that entire window, the plugin will continuously occupy 2 to 4 of those PHP workers just to handle the file and database duplication. That leaves 11 to 13 workers open. For a site with moderate traffic, this is plenty of capacity to successfully process standard visitor requests right alongside the clone operation. On a well-resourced plan, this math works perfectly. You have enough overhead to run heavy back-end tasks without ever disrupting the front-end experience. Knowing the exact mathematical capacity of your PHP worker pool is the only reliable way to predict whether your next staging clone will succeed or crash the server. Let's run that exact same math on an entry-level hosting plan where you only get 8 total PHP workers. You click the clone button. The staging operation initiates, instantly locking up 4 of your 8 available slots for the next 5 minutes. Right at that moment, you get a moderate spike in live traffic. The remaining 4 slots fill up instantly. Your container is now at maximum capacity. Any subsequent visitors trying to load your page have nowhere to go. They bounce off the full container and are forced into a waiting area, the server's CloudLinux LVE request queue. Visitors sit in this queue, staring at a loading screen. When the server's timeout window finally expires, the connection is dropped entirely, throwing a 503 service unavailable error. On a constrained plan, clicking Create Staging Site actively pushes your live paying visitors into a failure state. This animated flowchart shows the structural difference between standard Apache hosting and a LiteSpeed architecture. On standard Apache, every single visitor loading your site requires their own dedicated PHP worker. As traffic flows down the Apache pipeline, you can see each individual user consuming a worker slot, draining your resources before you even start a back-end task. But watch what happens when we flip the architecture to LiteSpeed and activate server-level caching on the live site. Incoming visitor traffic is now routed completely around the PHP worker container. They bypass PHP entirely and are served straight from a static cache layer. The immediate performance result is that cached requests are served in a fraction of a second, hitting a 16 millisecond time to first byte. The architectural result is even more important. Because those cached visitors consume 0 PHP workers, your entire entry process pool is left completely empty and available. Your staging plugin can now run at maximum speed, utilizing the full worker pool without ever encountering visitor contention. Server-level caching acts as a structural defense mechanism, shielding the entry process pool, so heavy operations can run without interference. Let's zoom out to look at the entire shared server. Your site is sitting on hardware alongside hundreds of other accounts. On generic shared hosting, this proximity creates the noisy neighbor vulnerability, where a single heavy user can drain the CPU and RAM meant for everyone else. If the account next door executes a runaway malware scan or an intensive staging clone of its own, its resource footprint will expand rapidly, putting neighboring accounts at risk. This is why CageFS and lightweight virtualized environments are a technical requirement. They wrap your account in an impenetrable virtual wall. CageFS ensures your specific allocation of memory and workers is guaranteed. It also ensures that neighboring accounts cannot view your sensitive cloned files. Professional, predictable staging is impossible without a hard mathematical boundary separating your architecture from the rest of the server. Once the infrastructure can handle the clones safely, the staging site becomes your most valuable tool for testing architectural changes. Look at this MultiPHP Manager interface. A high-value use case on cPanel is testing PHP migrations, like moving from PHP 8.1 up to 8.4. There is a strict operational order for this. First, clone the site and update all your plugins on the staging environment. Only then do you switch the PHP version to identify fatal compatibility errors. Local development environments often fail to catch these specific errors because they rarely match the exact stack. Staging provides the only exact one-to-one environment replica for verifying compatibility before risking your production site. This diagram highlights the danger for WooCommerce sites. Your staging database becomes outdated the second it's cloned, because production continues generating live traffic. If you perform a full push deployment, the static staging database overwrites production, instantly deleting those new orders. To deploy changes to a dynamic site safely, you have to use a selective push capability. The selective push deploys your verified changes while physically bypassing and preserving the WP users and WooCommerce order tables. A professional staging workflow requires infrastructure powerful enough to support the clone and a deployment strategy that protects your active customer data. That is how you close the loop on zero downtime development.